Operations on functions and function composition. This is a continuation of our lessons in functions. This is Chapter 1, Differential Calculus, Fundamentals and Applications. Given two functions f and g, the operations of addition, subtraction, multiplication, and division are defined as follows. F plus g of x is equal to f of x plus g of x. This is the sum of two functions. The difference of two functions is defined in this way. F minus g of x is equal to f of x minus g of x. The product of two functions is f times g of x is equal to f of x times g of x, and the quotient of two functions is f of g of x is equal to f of x over g of x. So what this says is, if we are given two functions f and g, we can produce a new function from these two functions, and we can do that by getting their sum, getting their difference, getting their product, or getting their quotient. And in fact, the rational function, the way we defined it is a quotient of two polynomial functions. The function that often appear in my mind whenever I am thinking of an example of a function that is a result of adding or subtracting two functions. And this one is found in business. It is the profit function. We know the profit function or the profit, the word profit to mean sales minus cost or revenue minus cost. And so from there, we can produce the profit function. The profit function P of x is equal to the revenue function minus the cost function. For example, let x be the quantity of egg sandwiches sold in a day. Let us say you own a space, a small corner in a mall, and let's say, for example, in this hypothetical situation, you are selling one thing only, egg sandwiches. And let x be the quantity of egg sandwiches that are sold in your snack bar in a day. Let us define the revenue function in this way. R of x is equal to 35 times x. So this is in pesos. 35 there is the selling price of one egg sandwich. So all in all, the revenue function is going to be the number of egg sandwiches sold times 35. What about the cost function? The cost function is equal to C of x is equal to 10 times x plus 450. Again, this is in pesos. You can look at 10 as the variable cost of producing an egg sandwich. The cost that goes into the egg, into the mayonnaise, the ketchup, the bun, etc. So you can look at this as the variable cost. This is the fixed cost. So maybe in this hypothetical snack bar, you are employing only one person and you are paying that person 450 pesos in a day. Maybe that is the minimum wage in your region. So C of x is your cost function. So we shall now produce a new function from these two, and we call that the profit function. And we define it in this way: the revenue function minus the cost function. 35 times x minus the quantity 10 times x plus 450. And that is the same as this. P of x is equal to 25 times x minus 450. So what is the profit when 15 egg sandwiches are sold in a day? So the profit is going to be P of 15. What is P of 15? It is equal to 25 times 15 minus 450. So these are in pesos. But it turns out that the difference is negative 75. So this store, when it sold 15 egg sandwiches in a day, it did not make profit. In fact, it is at a loss. It lost 75 pesos. Example. So suppose f of x is equal to 2 times x and g of x is equal to 1 minus x squared. Let us evaluate the following functions: f minus g of 1, f times g of 2, g over f of 1 half. F minus g of 1 is the same as f of 1 minus g of 1. What is f of 1? F of 1 is 2 times 1, which is 2. What is g of 1? G of 1 is 1 minus 1 squared, which is 0. So f minus g of 1 is equal to 2. Let us evaluate f times g of 2. It is equal to f of 2 times g of 2. F of 2 is equal to 2 times 2, that is equal to 4. And g of 2 is equal to 1 minus 2 squared, which is equal to negative 3. And so f times g of 2 is equal to negative 12. Let us evaluate g over f of 1 half. So this is equal to g of 1 half divided by f of 1 half. What is g of 1 half? G of 1 half is equal to 1 minus the square of 1 half. And that is equal to 3/4. What is f of 1 half? F of 1 half is 2 times 1 half, which is equal to 1. And so g of f of 1 half is equal to 3/4. Function composition. Given two functions f and g, the function compositions of the two functions are, as I recall it, when I was a student, my professor reads this as f circle g of x. And we understand it to be function composition. So f circle g of x is f of g of x. G circle f of x is g of f of x. So let's say, for example, we have three sets, x, y, and z. What does function g do? Okay, so what it does is it is pairing the elements of x to a unique element that is found in set y. That is what g does to x. Okay, and then f will pair g of x to a unique element in set z. From my first discussion about functions, we can look at functions as actions. We have an input. The function, which is a predefined process, will act on our input and it will produce an output. Okay, so you have inputs, you enter them into a predefined process and it will produce a unique output. So we can look at function composition as a sequence of functions or a finite sequence of functions. So for example, we have a list of real numbers. Let's say, for example, our function g will sort that list of numbers. It will sort it in ascending or descending order. And so the output of that is a ranked data. Okay, it can be descending or it can be ascending. And then what happens next is, okay, so you can imagine that array of ranked data. You will place them in a conveyor belt and they will enter the next process, the next predefined process, which in this case, we can call it the function f. And what the function f will do is it will find the middle value. And then it will produce a result. And the result is what we call the median. So you can look at a median as a composition of two functions. Let's say, for example, we are working on the same data set, okay? what is this? Okay, this is getting the sum of x sub I. Okay, so we have a set of data. We will put it in a conveyor belt. The conveyor belt will bring it into this box. This is the function g. And what it does is it gets the sum. Summation of x sub I. Whatever the sum is, that sum will be placed in the next conveyor belt and it will enter the next function. And what the next function does, this is function f, is it divides the sum by n. And the output of function f is going to be what we call the mean or the average. So you can look at the process of finding the median and the mean to be examples of function compositions, okay? Function composition example. We are working on the same functions f and g. Let us evaluate the function composition f circle g. What is f circle g of 1? Okay, so what we do first is we shall evaluate g of 1. So that is the same as this. Okay, and how do you interpret this? What is the sequence of function evaluation that you must do? Well, you will start with g of 1. Okay, what is g of 1? G of 1 is equal to 0. And then, what is f of 0? So f of 0 is equal to 0. Now, let us evaluate g circle f of 1. It is the same as this. So this means f will act on 1 first. And what is the result? The result is 2. 2 times 1 is 2. And then g will act on the result of f of 1. And that is equal to g of 2 is equal to negative 3. So here, we are seeing that function composition is not necessarily commutative.